So previously we were just looking at arrays, and if you want to check out that video, it's in the Creative Coding channel called Arrays in Processing. But here we're going to assume we know roughly how to use arrays, but let's do some things with them so that we can learn how to manipulate them effectively. So we've already seen how to search through an array for a particular value, but I think we'll just start with that again. So check if a value appears in an array. Now I'm going to do this two ways, and I want you to watch. The first way we've already seen, and then we're going to change it a bit. So first of all, we have an array. We'll call it numbers, and we will this time create this array, but it's going to be empty to start with, and it contains 100 numbers. So if you haven't seen this syntax before, you did probably see in the last video that we create an array which is full of ints, and it's going to be a list of numbers. That's the array. It's called numbers. We make it equal to a new list which is all ints, which contains 100 spaces. So the value 100 may or may not appear in it, but it contains 100 spaces to put values. So that means our index starts at 0 and goes to 99, which is the length of the array minus 1. Okay, so how would we fill that array with values? So let's do it. We're going to fill it with random values. Fill array with random values, and we can pick the range of the random values, whether they go from 1 to 100. I'm going to go from 1 to 10. Okay, so values 1 to 10. Okay, so a random value in the range of 1 to 10. Again, you can completely change this yourself, but watch how the code gets made. So I'm going to use our friend the for loop. I'm going to use I as our index variable. I'm going to start at 0 while it's less than the numbers dot length, just like last time, and go up by 1 each time. And here is where we're actually using a little bit of processing, believe it or not, but we're going to say put into numbers, and we use square bracket notation to define how we access an array. So when you see a square brackets with something like I inside it, that means look inside an array called numbers. We know it's an array because of the square brackets, and look at position, what's inside the square brackets. So because I is there, and we know I is a number which goes from 1 up to 99 in this case, we don't know which one it is at that particular point in time of reading the code. We won't know until the code is running. And imagine you could stop the code and say, well, which point are we on? Let's say we're on point 50. Well, then look inside the array and see what's there in 50. Right now there's nothing in the array. We're going to fill it with values. So we say int random 1, 10. Now what does this code mean? So this looks a bit crazy, but random returns a random number between a minimum and a maximum. So that's going to bring us back something between 1 and 10. And this here is called casting. By doing this, we're saying convert the value that comes back into an integer. That means if it brings back, say, 1.2, it'll cut off the 0.2 and just give us back the 1. And we need that because we said everything going into this array will be an integer. So we need to stick to that rule. So at this point, we might want to print out what's in the array. So I'm going to say print line numbers like that. So I'm going to hit run. And if we've done it right, we will get, you can see it here. I'm going to scroll up. All the values are between 1 and 10. Now it's not 10 inclusive, so it goes as high as 9. So it's 1 to 9. That looks right. And you can see the last index in the array is 99. So now that we have our code which fills our array with numbers between 1 and 9 inclusive, we now want to do something with that. So let's do something like our first question, which is check if the value appears in the array. So we're going to change our comment and say create empty array with 100 spaces. Fill the array with random values, I can take out this line. I don't need it anymore. I'm going to say check if a value appears in the array. Now you remember, if you watched the previous video, we always check for the number 6. That was the only number we checked for. I want to change that a little bit and say, well, first of all, we can check for just the number 6 or any number. But what if we wanted to change it so that we could specify different numbers and get back an answer for that number? We do that by using a method. If you learn programming in a previous era, you might call it a procedure and maybe a function. And sometimes people would differentiate a procedure and a function by whether it returns a value. But right now, I want you just to watch what we do here, and we'll explain as we go on. We're trying to make it so that we can create a piece of code that we can call and give it specific instructions to achieve something. So watch. I'm going to go down here a little bit. Now, so we will say check if a value appears in the array. Int value to find. And we're going to make it equal to any value we want, but I'm going to make it equal to 3 in this case. Then we're going to do our for loop again. And you'll notice it's exactly the same as previously, because we're going to go through it looking at every single point on the every index in the array. And we'll say if the number we are currently on is exactly equal to the value we are trying to find, which we defined previously, then print out, print out value to find found at index plus I. So we expect it to print out every time it finds a tree. Okay, oh, and I've made an error. I forgot to put a plus here. Let's put that plus in. Now we run. And we scroll up here. We expect to find quite a few trees. And we got one at position 5, 9, 10, down to 94. So that looks about right. Now, we don't necessarily want to print out where it was found. Maybe we want to print out how many were found. So we can change our code slightly to do that. Int count found. We started off at 0. And then down here, if the number matches, instead of printing it out, we just say count found plus plus, which makes count found, which started at 0, go up by 1. At the very end, we print out our message. So we print out a message saying we found this many count found instances of the value we're looking for. That'll be different every time because they're always random numbers. So we found 12 instances of tree. Let's run it again. 15 of tree, 6 of tree, 10 of tree. And because they're random every time, because we don't know what values are going to be in the array every time, but we'd expect there to be, a distribution. Because the values are between 1 and 9, we'd expect there to be roughly 10 of them, in the array each time. Now, what we're doing here is showing you how we can analyze the array, really. Okay, so the value we're looking for here, in this case, was 3. Let's change it to 1 and run again. We found 5 instances of 1. Now I'm going to change it to 11. And if you were following, you'll know that we create the values between 1 and 10. So 11 can't appear. So we expect to get 0 instances of 11. And we got 0 instances of 11. Now, I hope you don't mind, but I've just paused so I can shrink down the font a little bit. I like having a large font for the video so people can easily see what I'm doing. But I'm getting to have too much code now, so we need to do that. So we're back at our original code, and what we're going to do now is convert this a little bit more into a processing program rather than sort of a Java snippet. And to do that, we're going to introduce the setup method. Now, you've probably seen this if you've been doing processing for a while. Setup is a special method which is called once and only once at the beginning of your program. And then draw is usually used to do something several times a second. In our case, we're only going to use setup. We don't actually need draw. So we're going to leave certain bits of code outside of setup because it's what we would call accessible to the entire program, or global variable in a way, and we want to be able to use it everywhere. So we're going to leave that there. We're going to type void setup. Setup has two brackets here which have no input, and that means it's a method which takes no parameters. Okay, and the first thing I do is I keep the code which fills the array with random numbers. I could actually put that array in here, but then I'd have to pass it to my methods in the future, and I don't want to do that at this point in the tutorial. So we have code down here which checks if a value appears in an array, and I'm going to change the value to find to be a random number. I'm not going to know what it is in advance, same range that we did before, and I'm going to say that the count that is found is equal to a find count of the value to find. Now you'll notice I get a red line underneath that because I have not written that method yet. I better go write it. So find count value, well, let's go down and write that. So I'm just going to put a few spaces in here and go down to the very bottom and take this line and put it up here. Okay, and then close curly brackets. That's the end of my setup. Okay, so it has 3 lines. Create a random value to find, create a variable called count found, call a method called find count value, which takes in a parameter value to find. So what's a method and a parameter? And by the way, your lecturer or teacher may call this a function or procedure. It doesn't matter. And whatever they've called it, we're trying to find something and we're going to have to create that. So if we have a method, function, or procedure which returns a value, we give the type of the value, in this case int. Then we give it a name. We already know the name, it's find count value. Then we open a bracket which tells us what type of thing it is, and we tell it what type of parameter it gets. In this case, it's an integer, and we call it value to find. And then we give open and close curly brackets, put in our code. We actually already have our code here, most of it anyway. And then close our bracket. And we need to add a line at the beginning, which is int count found equal to 0. And down here, we need to return the value of what we found. Okay, so we didn't add very much to change that into a method or a function, but this is very important because the signature of the function is return type, name, normal bracket, not square bracket, parameters if any, curly bracket, code, return if you're returning a value, and curly bracket. Now, we actually had already written all of this code. We added in the return line and we left our int count found line up here because we were going to need it up there. So when I run this code, I expect to get a slightly different answer each time. So we found 13 instances of 6, found 10 instances of 1, 15 instances of 6, 13 instances of 5, 15 instances of 4, and so on. Okay, so what's happening here is it counts how many items appear every time. Now let's change that a little bit, okay? Because now that we have this nice find count value, let's do something a little bit cool with it. So let's do something different, and what we're going to do is here we are going to put in a loop, another loop. I know you guys think I use loops far too much, but I love them. So let me do very interesting things. So we'll say 10. Okay, and we will say then on the next line, curly bracket. We take this out here, and we replace this value to find with I, and then we replace this with I as well, and then close curly bracket. So what this code does is it says find the number of i's that occur, and I is a number which goes between 0 and 10. We should really go between 1, shouldn't we? Yeah, because there are no zeros in there. So 1 up to 9, or 1 less than 10, find out how many of those values occur, and it should print it out. So let's test it. So it found 7 of 1, 5 of 2, 13 of 3, 15 of 4, 11 of 5, 14 of 6, 13 of 7, only 3 of 8, and 16 instances of 9. And if you were to add those all up, they should come to 100. I'm not going to do that. I'll leave that for you to do if you're very bored. And we'll run it again and we get different values. I wonder, would we ever get 0? 0 items occurring. It's definitely mathematically possible. So we might have to run it for a while until we actually got 0. Okay. Now, next what we're going to do is analyze the array in different ways. So far we have a method or a function which can find the number of times a particular value appears. Now we want to do something different. We want to say, so that checks if the value appears in the array. Next, we're going to say print the sum of the array is, and we're going to call the method sum values and pass in actually we don't have to pass in anything because we only have one array. Usually when I'm teaching coding I would actually pass in the array we're going to sum the values of, but we're making it a little bit easier on ourselves by making numbers available to everyone everywhere in the program. So let's go down here, and actually I'll put it here. We'll say an int, the method is called sum values, no parameters, curly brackets. We're going to return the sum. Okay, we don't know what the sum is yet, so we say int sum equal to 0. And now we're going to do our loop. So I'm actually going to copy this loop up here because I've already written this. Okay, and here we'll say sum is equal to sum plus the item in the array at this position. Okay, now some of you, your lecturer or teacher, will have written sum plus equals numbers I. Okay, and that is a slightly shorter way to write it. Plus equals here means exactly the same as sum is equal to sum plus. Okay, so sum plus equals and is the same as sum is equal to sum plus. All right, so what that does is it'll keep adding every item it finds in the array to sum, and at the end it returns sum. All right, we're missing a bracket up here, so let's just put that in there. And now when we hit run, it should print out them all and then say the sum of the array is 471. Let's run it again. 490, run it again, 521. Now, it's quite possible that we would want to do more than just sum the values. We might want to sum the values until we hit a particular point and then return how many items we had to read till we hit that value. So let's think about how we would write that. Okay, so we might say int target value equal to 300. Okay, because we just ran it a few times. The sum was between 470 to 520, so 300 is probably going to be very common for it to get to that point. And we will say int how many values to sum. So how many values do we need to get to that sum, equal to calculate, or just calc sum values. That's probably a very bad name, but we're going to pass in the target value and we return how many items we need. Values is probably wrong. Yeah, well, okay, so I've probably named this badly. We're not trying to be confusing, but what we're trying to show you is that we can get the following. So we want to sum all the items like we just did, but to stop counting items when we hit the target value. We should say target sum actually. So yeah, I want to make this a bit more clear. Okay, target sum. Okay, I will say how many values to reach sum. This is me trying to rewrite this to be a little bit more clear, because sometimes your brain runs faster than you can explain. And that's still a very bad name. So we should think of a better name for that method, but I can't think of one right now. So I'm going to change this as well. So we say int num values equal to 0, and then we return the num of values. Okay, and I'm not putting in an error check in case it is a possibility that we would never reach that value, and I should put in a check to make sure that happens, but we're not doing that. So what we do here is we take this sum calculation, we already have it, okay, and we're scanning up through all the items and we're adding the sum, and if the sum that we've reached so far is greater than or equal to our target sum, that means we've reached it, and we should return the number of values it took to get there. And in this case we could just actually return I, which is the index into the array, so we don't actually really need int num values. So we're adding up our sum as we go along. I is the number of items we've looked at so far, and if we hit our target sum or go over it, return I, and if we don't, we're going to return -1. Now this is a dirty little trick. What returning -1 means to us is that we never hit the sum. Okay, so if we get to this line, it means we never actually reach the sum, because we would have returned at that point. So instead we should do a check here and say if how many values to reach sum equals -1, we never made it. Okay, and we print out a message to that effect, print line, the values in numbers array do not add up to target sum. Okay. Otherwise, print out the message, slightly different message. The number of values needed to reach target sum is now. What this means is that we have got a way of analyzing, if we have a number like 300, how many of the values in this big array of 100 items would we need to reach that sum, reading them from the first one to the last one. So if we run our code here, and oh, I've got a badly written thing here, so we go up here and we should say print ln. Sorry about that, guys. We'll run it again, and the sum of the array is 492. How many of those 100 items do we need to reach 300? The answer is 59. Okay, now if we change this number to be 400 and run it, it goes up to 75. Now let's change it to a number which it probably won't reach, 600, and the values in the numbers array do not add up to 600. Let's change it to something very low, like 10, and it turns out that the number of values needed to reach 10 is 1. Now that's probably not exactly right, because the first value is 9, and then you add anything to it, it's then gone over the limit, so it's 1 or 2. Okay, so there we had some very small numbers in our array to get there. Okay, now there's 14 instances of 1. Now what we're really doing here is showing you how you can do slightly more complex things with arrays, but you'll notice it's nearly the same thing every time. We have a function which takes in parameters and has a name and returns a type of value, And then the code is very similar to writing the code in any other way. You have a return value, but you'll get the hang of those very quickly. And so far we have find the count of the values, just sum the values, calculate how many values we would need to get to a target sum. And we can keep making lots and lots of these. The idea is that we're not really manipulating the array, but we're analyzing the array. And the really, really nice thing is we're writing methods to do it. So our setup here is simply calling all these methods and getting the results at once. Now look, guys and girls, arrays are hard. They're not something that you pick up straight away. They do take practice. I've seen people wrestle with arrays for a long time, but they are doable. You can learn this stuff. It's not there to make your life miserable. But once you have figured them out, arrays are very powerful and you can do very interesting things with them. Okay? Now, I know that most people are not excited to do arrays, but it is a very important part of learning computer programming. Okay? I hope that has made manipulating and working with arrays a little bit easier to understand, particularly when we want to write a method to find something out. Again, this is something that you will only really get good at with practice. There's an awful lot of material online, especially on YouTube, about arrays and processing, but sometimes we're not doing an awful lot of processing. We're really just doing introductory Java, as I said. So stick with it. It is quite difficult at first, but you will find it gets easier the more you practice with arrays. Okay, so I'm going to finish this one up. Good luck with all the homework, study and revision out there.